Here is another practice question for electromagnetic waves, and again we're dealing with power and intensity. So imagine that we have a star 55 million light years away, or a star 460 million light years away. I think that's what Betelgeuse is. So Betelgeuse is a star that's been behaving weirdly and could go supernova, and it would be super, 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 super bright, and that would be awesome. But imagine that this one is 55 million light years away, and we want to be able to detect it as a supernova. The human eye can detect an intensity of light as low as 10 times 10 to the negative 7th watts per square meter. So if it's less than that, we can't see it. If it's greater than that, then we can see it. So what would be the minimum power output of this supernova so that we could see it if it's 55 million light years away? Let's go. Okay, this isn't too difficult of a problem, but it's kind of fun. And there's some unit conversions, stuff like that. Okay, so I know the minimum intensity. Remember, intensity is power over area. And so if I have a star right here and it's producing a power, that's going to be spread over the area of a sphere, which is 4 pi r squared. So that has to be spread over that whole thing. So I want to calculate the power. So I know the power is going to be the intensity, which is that, times the area, which I'd calculate right there. Now the one thing I do have to do is to find the distance. So the distance here is 55 million light years. So 1 light year is the distance that light travels in 1 year. So it's going to be the speed of light, 3 times 10 to the 8th meters per second, times the length of a year, which is going to be 365 days times 24 hours times 3,600 seconds. So 1 light year in meters, right? We need it in meters. Let's calculate that. It's going to be 3 times 10 to the 8th, 365, 24, 3,600. And I get 9.46 times 10 to the 15th meters. That's the distance in that. So now I can calculate the power. Let's just put in our numbers. It's going to be the intensity, 10 to the negative 7th, times 4 times pi times 9.46 times 10 to the 15th squared. And so I already have that one in there. Square it. And then multiply by pi. Oh, crud. Multiply by 4. Multiply by 1 times 10 to the negative 7th. Okay, 1 exponent, negative 7. Because I've already got the, don't do 10. Where's my negative? There it is. I get 1.12 times 10 to the 26th watts. That's the power output of the star. And a supernova, I think, is way higher than that. But there you go. Star problem.